It's already Halloween and I can't wait to get candy. I'm hoping to get some more Skittles or Starburst this year. Just whatever I get, I hope I don't get any more stupid circus peanuts. It sucks that I already get them 33% of the time. Maybe I'll get a higher percentage of chocolate this year. Just no more circus peanuts. Halloween was terrible. When I went trick-or-treating, it started off good. I got normal candy, but then I got not one, not two, but 3 circus peanuts in a row. Thankfully, I got some more normal candy, but after that, I got 1, 2, 3, 4, 5 more circus peanuts in a row. I got some more normal candy, but I had to return all the circus peanuts back to Costco where they belong.
This was an interesting question.
Are circus peanuts becoming more popular this year?
I sure hope not. Did you see how many they got this year?
Let's run a simulation to figure it out.
Yes, a simulation would help us figure out if this is likely or not. Now it's time for us to set up the simulation. In a simulation, it is an imitation of chance behavior. But first we have to state the question. Then we have to plan the process. Then we have to do the process, which is actually conducting the simulation through the plan process. Then conclude, which is creating a conclusion from the data that we've drawn. First step, we have to state the question. The question being, was the instance in which Mrs. Halloween Bag got 5 circus peanuts in a row, does that mean that people are getting more circus peanuts? Then we have to identify the assumptions. The assumptions being that each house is independent, or each house has an independent chance from another of drawing circus peanuts or giving out circus peanuts. Then also that there is a 33% chance that circus peanuts will be given out.
Then the second step is to plan the process. The first thing we must do when planning the process is assign digits to simulate the situation. You can do this multiple different ways, but we chose using a die. You can also use a random digits table or a calculator to generate random numbers. We use the digits 1 and 2 on the die as the chance of getting circus peanuts, and 3 through 6 the chance of getting other candy. This makes the chance of getting circus peanuts 1 out of 3, or around 33%. We then run the simulation 20 times, and after that we tally up the results of the simulation.
Next, the third step, do, is to follow the planning process. We chose the numbers 0, 1, and 2, and those numbers popped up 5 times in a row, 5 times out of 15 times, or out of 20 times, versus the 15 in which those numbers did not show up 5 times in a row. Now, after performing the simulation, we can conclude that getting 5 circus peanuts in a row is not unusual, because 5 out of 20 is 25%. This means people aren't handing out circus peanuts more often. However, it was pure chance that they got 5 circus peanuts in a row. So, Miss Halloween Candy Bag doesn't have to worry her head about getting more circus peanuts, thankfully. As I said before, this data is really interesting. It really does show that circus peanuts
Hold up.
are not.
I'm gonna put these guys on mute. So you're telling me that even though people are not handing out more circus peanuts this year, that it's still possible for me to get 5 in a row? I hate these stupid circus peanuts. I hate Halloween.